Hello everyone, welcome back to Nunley Math. Thank you so much for joining us here today. I'm Aaron Nunley. I'll be hosting you as we talk about integers and orders of operations. If you've been following along in our series, you know that we've talked about the different operations with integers, adding, subtracting, multiplying, and dividing. Primarily, we've looked at those one at a time, but as we work our way into more and more complex problems, we need to make sure we understand how mathematicians organize or sequence their work when there are these larger problems. And most of you will probably already be familiar with what we refer to as the order of operations. So here's the order of operations as you probably learned them in elementary school. Parentheses are always done first. Parentheses is a generic term that's used to define all grouping symbols, followed by exponents. Exponents would include square roots because, as we learned a little earlier, they are kind of inverses of one another. Then you learn multiply and divide from left to right, and add and subtract from left to right. And most people have memorized the saying, "Please excuse my dear Aunt Sally," in order to help them keep track of which one comes first. And then some of my students will also come to me and just use the word Pemdas, parentheses, exponents, multiply, divide, add, and subtract. And this is actually a pretty good tool for keeping track of things, especially for younger students who have difficulty understanding how to prioritize. However, it does have some drawbacks. I would suggest to you that we would be far better served if we learned it this way. Please stands for parentheses, excuse stands for exponents, and then notice I've put my dear together. That's because we don't multiply and then divide in order from left to right. Rather, we treat multiplication and division as equivalents to one another, meaning that we both do both of these at the same stage. So if division happens to arrive in a problem to the left of multiplication, we would do that first. Notice I do the same thing here at the end with Aunt Sally, where addition and subtraction are done essentially at the same time in order from left to right. So if subtraction happens to come before addition in a problem, we would do the subtraction first. Notice I write it this way. Please excuse, my dear is now underlined, and Aunt Sally is underlined as well. I think this is going to help us avoid a popular misconception. Now, I've got an example here for you. I'm going to talk you kind of through how I would walk my students through this problem. Notice when we do this, there are several different operations here. There's the addition, there's a multiplication right here, there's a subtraction, and there's an addition right here. Now, a lot of people get confused by these parentheses right here. They say, well, order of operations says I should do parentheses first, and that's true. However, if you look inside of here, there's no operation inside of those parentheses. Rather, those parentheses are just there to help us realize that this -2 is a single unit that is being multiplied by the 3. It's kind of a grouping or organizational mechanism, just so we realize that this is a times rather than a 3 minus 2. So when I look at this, there are no parentheses in this problem other than the ones we suggested or talked about, and there's nothing to do inside of those. Notice there's no exponent in the problem either. That takes us to multiplication and division. When I look through this problem, I only see multiplication and division occur in one spot. That's right here, the 3 times a -2. If you remember from our integer rules, 3 times -2 becomes a -6. Now, I want to stop here and talk to you about a couple of things that I find very, very important that a lot of students skip over that creates problems for them. First of all, notice I took the time to underline the change that I'm making and then to rewrite the entire problem exactly as it appears with nothing changed except for that one specific operation I've already done. Two reasons for that. Most students that I've worked with, especially early on, like to get in the habit of doing multiple things at the same time. And you have to be very cautious about that, because if you're not being careful, you might accidentally do something out of order. It's a very common thing to occur, and I just want to make sure that we're at least aware of that. So I require my students to do the underlining and then to rewrite the entire thing. By rewriting the entire thing, we make sure that our students are not losing track of stuff. So for example, sometimes I'll have students that will try and write the -6, and then all they'll write down is the -5 plus -6, and they'll forget about writing down the -11 and +14. Really, really bad habit, because what ends up happening is they start trying to reconnect it later on, and sometimes they forget things. Also, when we talk about algebraic thinking, which is really where we're headed with this, it's important for us to realize that we have to be able to explain or demonstrate to somebody who's reading our work that what we're doing adheres to the rules. So even though you may be able to do this in your head and calculate it correctly, in my class, I would give you absolutely no credit unless everything was shown as I've asked. Anyway, next up, I look and I see I have an addition, a subtraction, and an addition. According to my order of operations, adding and subtracting should always be done in order from left to right. Remember, we do not prioritize addition over subtraction. Rather, we look for these two things at the same time. So when I begin over here on the left, you'll see I have -5 plus -6, which makes -11. Notice once again, I made the one change and I bring everything else down. Also notice I'm doing my best to keep things lined up. It's not always possible depending on the spacing in your page, but you really want to make sure that you do your best to keep those lined up, because once again, it helps you to not lose track of things. Next step is this subtraction. Notice that the subtraction does come before addition because I do not prioritize addition first. Rather, I'm just working left to right. Also notice that because I have subtraction, we learned in our subtraction of integers unit that subtraction is a little bit difficult. So I'm going to go ahead and rewrite this subtraction as adding the opposite. If you're unclear as to what I just did there, go back and watch the subtracting integers video. That should make more sense for you. Notice -11 plus -11 is a -22. And that just leaves me with this final operation. -22 plus 14 is -8. Notice that I can look back through here very quickly and I can see the work so that I understand what was being done. Also, if I have an error, I can go back one step at a time and I can find exactly where that error might be. Here's another example. You might want to consider pausing the video and trying this on your own before watching me do it. I'm going to do this again using these order of operations. This time I'm starting with my parentheses or grouping symbols. In this case, the only operation that takes place within parentheses is this -9 plus 4. Remember, this parentheses is just to help us recognize that this is not a 14 minus 2, rather it's a 14 times -2. But anyways, -9 plus 4 gives you a -5. Notice I bring everything else down exactly as it appeared, and then I start looking for what is next. Exponents. I don't have any exponents. Multiply and divide in order from left to right. Well, I've got multiplication here and multiplication here. This one's on the left, so I'll do it first. Then I've got multiplication over here on the right. I'll do that second. Now that all the multiplication division is done, I'm looking for adding and subtracting. I have a subtraction sign here, an addition sign here. We always work in order from left to right, so I do the 7 minus -30 first. I'm going to take the time to rewrite that minus -30 as a plus positive. Again, subtraction tends to be fairly difficult for people. You're much better off to change it to the equivalent addition problem. If you don't know how to do that, you're going to want to go back and watch the subtraction of integers video. Now, 7 plus 30 is 37. Add that to a -28, and you get a positive 9. Not too bad, right? I would like to point out up here that if students have a tendency to do more than one thing at a time, one of the very common mistakes that's made is they like to add what's inside here first, and then to also go ahead and subtract the 7 minus 6. They often forget this is multiplication, and that multiplication has to be done first. Here's another example for you. Once again, I'd suggest that you pause the video, try it on your own, and then watch. I'm going to do this one a little faster this time. Parentheses first. Notice I rewrite everything exactly as it was given to me. The only change that I made was the 4 minus 9. Second thing I'm looking for is the exponent. Notice there are two exponents. I work from left to right. This one's first, this one's second. 3 to the third is 27. And now I'm going to do this one over here. That's a negative 25. This tends to be a trouble spot for students. A lot of students see that minus negative and they think, oh, minus negative becomes plus positive. But remember, order of operations says that we need to do the exponent portion first, which means I need to take care of that negative 5 squared before I deal with this negative sign out here. Negative 5 squared is 25. Then I stick the negative sign on and get the negative 25. Another way to think of that is people get confused because they think there are two negative signs. There's actually not two negative signs because this says I have two negative signs inside the parentheses and one more on the outside for a total of 3. Notice now I'm down to addition and subtraction, so I'm going to do my addition first. Negative 8 plus 27 is 19. 19 minus 2 comes next. And then 17 plus negative 25 gives us a negative 8. Not bad, right? Last one. This one is a little more complex. Notice that I've thrown in a square root for you. I've also thrown in this long division bar. A long division bar acts as a grouping symbol. So we're actually going to treat this like a parentheses or P. That means everything on top has to be done, then everything on bottom has to be done as if they were both in parentheses, and then the division is going to come after. Did you catch that? Do the top, do the bottom, then division is going to come after. Now, because I have that long division bar, I actually have a little bit of flexibility in terms of how I deal with this, because I know that, can I get rid of that? There it goes. I know that when I go to do this, there we go. When I go to do this, whatever I do on top has to be completed, and then everything I do on bottom has to be completed, and then the division happens last. Since the division happens last, I can really simplify the top and the bottom at the same time. Technically, if I was thinking left to right, I probably should do this entire thing first, this entire thing second, and then do the division. But since the division's happening last anyways, I'm allowed to do them both at the same time. So if I look at the top and I'm looking for what comes first, I'm going to do what's on the innermost parentheses, negative 3 plus negative 7. When I look at the bottom, the first thing I'm going to do is what's inside of this grouping symbol. Notice it's absolute value bars. Inside of there, I have subtraction and an exponent. So on top, I do the addition first. On the bottom, I do the exponent first. And that gives me this. Negative 3 plus negative 7 is negative 10. On the bottom, the 4 squared is a 16. A lot of people get confused because they ask, isn't this negative 4 times negative 4, which would be positive 16? Remember, deal with the exponent first, then deal with the subtraction sign. Now that I'm down here, when I look at the top, parentheses are taken care of. Remember, these parentheses are just to separate those negative signs. That brings me to the exponent. So I'm going to do the exponent right here on top. On bottom, I'm going to do what's inside the grouping symbol, which is the negative 8 minus 16. Now I believe, yes, I did not take the time to write this as a plus negative for the sake of space on the slide. Negative 8 plus negative 16 is negative 24. I would recommend to my students that they take the time to redo that. That brings us down to here. Again, on top, it's all subtraction now. I'm going to work from left to right, so 5 minus 100. On the bottom, the only thing that's left is the absolute value of negative 24. So I'm going to make the top a negative 95 minus 1. The bottom becomes a 24. Again, this acts as a grouping symbol, so I'm going to do what's on top, and there isn't anything left to do on bottom. That makes this negative 96 over 24 plus 49. Now notice what's left. This is a division bar plus a square root. I'm going to go ahead and do the exponent or square root next. That's a 7. Then I'm going to do the division. That's a -4. And the addition comes last, giving us a 3. Here again, this has just been 4 quick examples reminding you of how order of operations work. In my class, we're going to start dealing with some more and more complex problems that are going to require us to be able to do this, so I thought it was worthwhile to have a quick refresher. As always, thank you so much for taking the time to watch. Make sure you leave us a comment in the comment sections. We know you're out there. Make sure that if you have any questions, you ask those there. If you have any advice for us, we'd love to hear that as well. Make sure you hit that like button and your subscribe button. Ring that bell for some notifications so anytime we post something new, you'll be sure to keep up with us, all right? Thank you guys so much. Take care of yourselves. Best wishes. Bye-bye.